XDR2 is the world's fastest DRAM technology, a dramatic leap in memory performance, the first fully differential memory architecture, the ideal solution for the next generation of consumer electronics. The XDR2 memory architecture offers higher performance than GDDR5 for gaming and graphics, the ability to supercharge multi-core computing applications, all at significantly lower power. Next-generation graphics and gaming processors will require unprecedented levels of bandwidth. The desire to display thousands of objects on screen with real-world physics and ultra-realistic imagery will drive memory bandwidth requirements to as high as 500 gigabytes per second in the near future. As the next generation of the award-winning XDR product family, XDR2 provides system designers the ability to reach these unprecedented levels of memory bandwidth. With a roadmap to over 12.8 gigabits per second, XDR2 DRAM operates at 2 to 3 times the data rate of GDDR memory solutions. At XDR2 data rates, memory bandwidths of 500 gigabytes per second are well within reach. At the same time, XDR2 provides better pin efficiency, lower overall pin count, and full forward and backwards compatibility with XDR DRAM, allowing today's designs to benefit from tomorrow's performance. The XDR2 memory architecture is a complete memory solution, encompassing XDR2 DRAM, an embedded XCG clock generator, and the XMC digital controller, all enabled by key Rambus patented innovations. As the industry's first fully differential memory architecture, it's ideal for next-generation high-performance gaming, graphics, and multi-core computing applications. At the heart of this architecture is the XDR2 DRAM. When operated at full speed and a 32-bit wide configuration, a single XDR2 DRAM can provide over 50 gigabytes per second of memory bandwidth. That's equivalent to the memory bandwidth of 8 to 12 DRAM devices used in current-generation graphics cards or game consoles. In fact, XDR2 DRAM delivers twice the bandwidth of GDDR5 graphics memory and does so with far better power efficiency. At equal bandwidth, XDR2 memory operates at 30% lower power than a GDDR5 memory system. And for an equal power budget, XDR2 memory delivers 50% more bandwidth than GDDR5. This combination of superior bandwidth performance and superior power efficiency gives designers tremendous flexibility in implementing high-performance next-generation consumer electronics. Rambus's history of innovation has delivered the patented inventions that make possible the breakthrough XDR2 memory architecture, the latest generation of the award-winning XDR family of products. Many of these innovations were developed through Rambus's groundbreaking Terabyte Bandwidth initiative. Realized in the XDR2 architecture, these innovations enable memory systems capable of over 500 gigabytes per second of bandwidth. The first of these innovations is 16x data rate technology. Unlike conventional DDR or double data rate memory, which transmits 2 bits per clock cycle, 16x data rate transfers 16 bits of data per clock cycle. This unique approach allows the XDR2 memory system to run at data rates as high as 12.8 gigabits per second, while maintaining economical and relatively low system clock speeds. Operating at these high speeds requires a very robust signaling architecture. In XDR2, this is achieved through FDMA, the industry's first fully differential memory architecture, an innovation developed through Rambus's Terabyte Bandwidth initiative. FDMA incorporates differential signaling on all the key signal connections between the memory controller and the DRAM. The benefit is improved signal integrity, reduced power, and the highest memory performance available. Building on Rambus's patented FlexPhase technology and XDR memory, XDR2 includes enhanced FlexPhase. Enhanced FlexPhase allows for flexible phase relationships between signals, creating precise on-chip alignment of data with clock. Enhanced FlexPhase improves the sensitivity and capability of FlexPhase circuits for very high-performance memory and operation at data rates of 12.8 gigabits per second and above. FlexLink Command and Address, another terabyte bandwidth initiative innovation, reduces system costs and controller pin count, while providing scalable capacity and flexible access granularity. Running at full speed, or up to 12.8 gigabits per second in an XDR2 memory system, FlexLink CA makes it possible to implement the command and address link with as little as 2 wires versus the more than 20 wires needed in legacy memory. To address the finer access granularity needed at higher and higher screen resolutions, XDR2 memory includes Rambus's microthreading technology. Microthreading increases usable memory bandwidth by logically partitioning a traditional 8-bank DRAM core into 16 independently addressable banks. This reduces row and column access granularity, resulting in increased transfer efficiency on microthreaded workloads and lower power consumption. In combination, these breakthrough innovations make XDR2 the world's fastest DRAM technology, providing 2 times the bandwidth of GDDR5 memory, delivering best-in-class low-power performance, and making possible total system memory bandwidth of over 500 gigabytes per second. With XDR2, Rambus is architecting the future of memory. Rambus, your license to speed.
Hello, my name is Rob Dat, and I'm a Solutions Marketing Manager at Rambus. I'm here today to demonstrate the world's fastest DRAM technology, XDR2 memory. Operating at a peak data rate of 12.8 gigabits per second, XDR2 DRAM offers twice the bandwidth per device compared to GDDR5. XDR2 is the next generation of the award-winning XDR memory architecture. XDR DRAM is available today from major memory manufacturers. Now in high-volume production, more than 100 million XDR DRAMs will have shipped by the end of 2008. It has been selected for graphics-intensive applications such as Sony PlayStation 3, TI DLP projectors, and most recently, Toshiba HDTV applications. XDR2 builds on the XDR architecture and pushes memory performance to a whole new level. XDR2 features fully differential memory architecture and FlexLink command and address innovations which lower power, improve signal integrity, and allow for scalable capacity and access granularity. Microthreading delivers superior performance for high throughput applications with reduced access granularity. XDR2 uses the same differential I/O for both data and command and address links and increases the data rate scaling from 8x to 16x, which enables higher bandwidth. Enhanced FlexPhase simplifies PCB layout and eliminates the need to match trace lengths. What do all of these innovations combined bring you? Higher data rates with lower power than GDDR5. Let's compare XDR2 to GDDR5. Sourcing widely available data, GDDR5, by 2011, should be capable of providing 24 gigabytes per second of bandwidth from a single device. Today, with XDR2, you can achieve twice that level of bandwidth. Here we have a demonstration board featuring an XDR2 memory interface. The ASIC is generating a pseudo-random bit sequence that is fed into an XDR2 memory controller and XDR2 XIO. To obtain the performance I mentioned to you earlier, you do not need an expensive or power-hungry ASIC process. This test chip is fabricated using a standard off-the-shelf, low-power 65nm LP process. The differential memory IOs are connected to a pair of 16-bit sample memories. One of the memory IOs is taken to a pair of SMP connectors, which is connected to this scope. I'll set the clock to 800 MHz. During initialization, the controller goes through a calibration process. In this calibration process, 2 things are happening. First, optimal equalization coefficients are being determined and set for a multi-tap FIR transmit filter and linear receive equalizer. Second, the controller calibrates the optimal transmit and receive phase values to produce data which is optimally aligned to the reference clock at the DRAM interface. By implementing these features on the controller side, we keep the XDR2 DRAM complexity and cost low. As a result, you can see that the eye diagram is wide open. This is the benefit of having asymmetric equalization and enhanced FlexPhase built into the XDR2 interface. Let's add in the 800 MHz reference clock on the scope. Multiplying up the reference clock using 16x data rate scaling, we achieve a blazing fast data rate of 12.8 gigabits per second per link. The 12.8 gigabits per second is not an encoded rate, it's the actual rate achieved with the XDR2 architecture. How XDR2 achieves that is partly due to the use of differential IOs versus single-ended IOs used in GDDR5. With differential IOs, you get higher signaling speeds, superior noise immunity, and lower EMI than single-ended signaling systems. In addition, differential IOs can be run at high speeds on low-grade printed circuit boards. In fact, XDR2 architectures can be implemented on as few as 2 PCB layers. This demonstration board is constructed of standard FR4 material. No exotic processes or materials are required. This makes XDR2 memory well suited to the needs of consumer electronics and computing applications.